Hello, friends. Our universe is mind-bogglingly vast. It's perhaps the most incredible thing about it, and yet also the most frustrating. Even if we discover an Earth-like planet using our most advanced telescopes, the harsh truth remains. We might never reach it. Why? Because even our fastest spacecraft, cruising at 28,000 kilometers per hour, would take billions of years to reach the nearest galaxy, Andromeda. And even light would need 2.5 million years to make that journey. It's a harsh realization. So what's the point of discovering habitable worlds if we can't visit them? Well, what if we didn't have to travel the long way? What if there was a shortcut, a tunnel through space-time? Welcome to the world of wormholes. You've probably heard of them in movies, especially Interstellar. In that film, a wormhole appears near Saturn, allowing astronauts to reach a distant galaxy in minutes. It sounds like fiction, but here's the twist. Wormholes are actually based on real science. Let's go back to Einstein's theory of relativity. Einstein described how matter bends the fabric of space and time, what we now call space-time. Imagine it as a stretched sheet. Place a heavy object on it, and the sheet bends. The more massive the object, the deeper the bend. Einstein's equations were so complex, he couldn't solve them completely himself. But in 1916, Carl Schwarzschild found an exact solution, describing space-time around a massive sphere. This led to the idea of singularities, the foundation of black holes. But black holes aren't the only solution. In 1935, Einstein and physicist Nathan Rosen proposed another one: wormholes, bridges through space-time that could connect two distant points. This concept became known as the Einstein-Rosen bridge. To understand, imagine folding a paper so two dots, A and B, touch. Punch a hole through the paper and you've created a shortcut. That's a wormhole. It bypasses the distance between 2 points by curving through a higher dimension. Physicist John Wheeler further visualized this by comparing it to a worm burrowing through an apple. Instead of crawling on the surface, the worm cuts through the inside, just like a shortcut through space-time. In theory, a wormhole could let us travel across galaxies in moments, or even move through time itself. But we face challenges. First, how do we create or open a wormhole? We'd need immense gravitational forces, possibly from a black hole. Yet a black hole only pulls in. So how do we come out the other side? This is where the idea of a white hole enters. A white hole is the opposite of a black hole. Nothing can enter it, only leave. If a black hole pulls everything in, a white hole pushes everything out. They're time-reversed versions of each other, theoretically predicted but never observed. If a black hole and white hole were connected, it might form a stable wormhole, a tunnel, a gateway. But all of this, for now, is theoretical. Wormholes haven't been proven to exist. They are fascinating mathematical solutions to Einstein's equations, but building or finding one is another story. Still, the idea that we might one day unlock these cosmic shortcuts gives us hope. Maybe, just maybe, humanity's journey beyond the stars won't take millennia.